Hello class, this is going to be another video for related rates. Again, it's very difficult, so that's why I want to do a lot of examples for you. And this is an example where I'm actually going to use two equations to figure out this problem. So here, let me read the example, and this is in your notes. I skipped a couple problems because I wanted to find one that's a little bit different than the ones we did in class, and then we're going to practice more in class. But I want to do one for you on video, one with two equations. This one says example, a snowball in the shape of a sphere is melting so that its volume is decreasing at a rate of 5 cubic inches per minute. At the instant when the radius of the snowball is 4 inches, what is the rate of change of the surface area of the snowball? Alright, I know it's going to sound complicated, so let's just do the very first step, which everyone should be able to do. Let's draw a picture. And again, I'm doing this on a mouse, so it's not perfectly round, but here's my spherical snowball and it's melting. So here's my little drops of sweat. And it says the volume is decreasing at a rate of 5 cubic inches per minute. So since the volume is decreasing at a rate, I'm going to call that V prime equals, and it's decreasing, so I'll call that -5. At the instant when the radius of the snowball is 4 inches, okay, so the radius is 4 inches, so I'll say R is 4. What is the rate of change of the surface area? What is the rate of change of the surface area of the snowball? So I want the rate of change of the surface area. So surface area I'm going to designate as SA. And I want to know what that is. So really very little information is given to us, and I'm trying to solve for SA. Alright, so I did the first step. Here's my picture. I did my second step. Here's my knowns and unknowns. And my third step is to find the equation that I need. Now, this is your first time doing this, so some of you are going to be confused, like which equation do I use? I mean, there's no Pythagorean theorem, there's no area of a triangle, but you do notice that you have a sphere. And you notice two buzzwords. One's called volume, and one they mentioned at the end of it is surface area. I don't know which one I'm going to use, so let me just write both of them. And you might have to look it up on Google or something, but I see sphere and volume. The area of volume of a sphere is V equals 4/3 pi r to the third power. Surface area of sphere, again, you could Google this, but the formula for surface area is 4 pi r squared. Still with me so far? So in the past we only had one, like Pythagorean theorem or the area of a triangle, but in this case I have two and I don't know which one to use. Now, what was my next step after I found my formula? Yeah, I derived it. You'll notice that both of these, it looks like product rule, right? Like I'm multiplying two things, like this one and this one. But you notice, and this was also on your test, and the reason why, 4/3 pi is just what? Yeah, it's just a number. And same with 4 pi, that's just a number. So I'm just going to do a simple product rule. And I'll write the equation here on the side. V, the derivative of V is 1. And I'm going to put 1V prime. Equals, I'm going to do the straight power rule here. 3 multiplied by 4/3. The 3's will cancel, so I get 4 pi. And then I subtract 1, r squared. And then since I derived r, I have to add what? An r prime. SA, same thing. SA, the derivative of SA is 1, but then since I'm deriving implicitly, I'm going to add a prime. Then I have, again, it's just a number, so 2 times 4 pi is 8 pi. And then subtracting 1 is r. And then since I derived r, again, I'll add an r prime. Okay. Now, going back to the question, or going back to my knowns and unknowns, what am I looking for? Yeah, I'm looking for SA prime. This is the one that I want to know. So SA prime, I need to fill in and solve. So number 4 is solve. So let me write or rewrite SA prime equals 8 pi r prime. So let's fill in what we know. I know 8 pi. I know r is 4. What about r prime? What's r prime? Well, it's not in any of my equations, right? So what do I do? I'm sort of stuck. They didn't give me r prime. I can't derive it. I can't re-put it back into Pythagorean theorem or anything. This is the point where you use some critical thinking and you notice two things, or one of two things. One, you notice that they gave me a value, V prime, so your hint is you have to use it somewhere. And your other hint is that this also has an r prime, so this is a hint that maybe I have to take something from here and plug it into here. So let's solve for r prime. Remember I had another equation? Let's solve for r prime here. So here's my side calculation. Maybe let's do it in green. This is too small, but okay. So let's solve for r prime. If I divide on both sides, r prime is equal to v prime over 4 pi r squared. Okay, so far? V prime in my knowns and unknowns is -5. And my R, again, is 4. Is it 4? Yeah, 4. 4 squared is 16. 16 times 4 is 64. So it's -5 over 64 prime. Or 64 pi. So 4 squared was 16. 16 times 4 is 64. So -5 over 64 pi. Now that I have R prime, now I can plug in what I was missing here. So this R prime, I'm going to take from this original problem and plug it in here. Now I can solve for SA prime. I have pi's on the numerator and denominator that I'll cancel. Okay. On the top, I have 8 times 4 times -5. I'm going to have let's see, -20, -160. On the bottom, I have 64. And you can reduce that. Off the top of my head, I don't know how that reduces. I mean, I have -80 over 32. 8 goes into both of them, so -10 over 4. Then 2 goes into those, -5 over 2. So I found out that the surface area is decreasing at a rate. And the surface area, remember area is centimeters squared, and it's a rate, so it's centimeters squared per, or sorry, inches. This is all messed up. This is fun, isn't it? So let me cross this out. It should be inches squared per minute. So remember, you need the units. So now I have found out a related rates problem where I have 2 formulas and I got to use both to solve the problem. So I hope you enjoy. Again, you have 2 nights to watch this. Obviously, if you watch this now, then you watched it already. But you have 2 nights to do this, and I'm putting it into Power School, and it's too late. But hopefully you understand. Come to class tomorrow. Please bring your prep books, and we'll watch it together. Or sorry, watch it together. We'll do the problems together in your prep books. All right, take care. See you in class. Bye.